Hey guys, so today or this week we're going to cover three different standards for review, and they're going to be fairly related to or extremely related with Pythagorean theorem. And this other one, the rational irrational, kind of goes hand in hand because we start talking about some square roots. So rational and irrational numbers. To know a rational number, you need to know what an irrational number is. So a rational number can be represented by a terminating or repeating decimal. In fact, a rational number is anything could be written as a fraction. And there it goes right there. So anything, no matter how odd or strange the fraction is, negative and positive, um, all of those are what we call rational numbers. If you can write it as a fraction, it's rational. Um, Irrational go on forever and ever and ever. When you turn it to a decimal, it never stops, doesn't have a pattern. The most famous irrational number of them all, I believe, is pi, because pi goes on forever and ever, still going on. Square root of 7 is irrational because it goes on, and all these are irrational. Now, that doesn't mean all square roots are irrational, because the square root of 25 equals 5, and 5 is one of our natural whole numbers. And so 5 is rational, so therefore the square root of 25 is irrational. But if I were to put square root of 7 in a calculator, and I just type it in there, I'm going to get something crazy, and it's going to go something like this. I'm going to go about, because I'm going to round it at some point, 2.64577513111 goes on. Okay, I'm going to put little dots here. There's no pattern. I can't predict from that one what's going to be next. So there's no, it doesn't repeat itself ever. And so rational has an end or makes sense. Like 1/3, it's one of our most famous repeating decimals. Remember, it's a bar notation, but if I just kind of kept going, it's just threes forever. It goes on forever, but it's the same thing forever at that point, making it rational. Okay, so the next standard is the Pythagorean theorem, and I want to focus on, well, there's two equations up there, but I want to focus on this first one right here. Pretty famous, pretty popular. A squared plus b squared equals c squared, where c is the hypotenuse and a and b are legs. Actually, that would just be a leg, and that would be a leg. Okay? Sorry about that horrible handwriting. So what you do is basically take the two shortest sides, and you're going to square them, 12 squared plus 16 squared, and you're going to, the side opposite the 90 degrees is the hypotenuse, and you're going to say that equals whatever it is, c in our equation, but now it's x squared. So let's square everything first, okay? So 12 squared, it's pretty popular, is 144. And 16 squared, not as popular, but it's 256, equals whatever x squared is. So when we add those together, I get 400 equals x squared. Now I have to figure out what times itself equals 400. And some of you might already know that one, but I'm going to take the square root of it because it's going to cancel out the square. And so the square root of 400, I can use my calculator. The square root of 400 is 20 equals x. So this is 20. Now I can kind of tell if I'm right or close to right. This side needs to be longer than 12 and 16. Not combined, just longer than either of those, or both of them, but not longer than them combined. So that's something to think about. So if I change colors, we can do this one down here. Okay, I usually call the shorter side, the shorter leg A, and the longer side B, but you don't have to. And here's my C. So 5 squared plus 12 squared equals C squared. I think this one might come out nice as well. They don't usually come out this nice. 5 squared is 25, and we remember that 144 equals c squared. So I believe this is 169 equals c squared. Now remember, to undo the square, I do the square root. then the square root of 169 equals 13. Remember, I check my work because 13 is bigger than 12 and bigger than 5, but not bigger than 17, which is 5 plus 12. Okay, so now sometimes you're going to be missing a leg, and when you're missing a leg, it's subtraction. So we don't know what this leg is. So let's just fill in everything we know, though. We have the equation a squared plus b squared equals c squared. We're going to call this a. We're going to call this b. It just looks shorter. It doesn't matter. You can switch a and b. Doesn't matter. The only one we have to have a certain way is c. It's always across from the 90-degree angle. So leg a we don't know. B we know is 24 squared. And c is 26. Well, I'm going to square it. So let's do all the math we know. A squared plus whatever 24 squared is, which is 576, equals whatever 26 squared is, which is 676. Now we can solve an equation. We get the variable by itself. So let's subtract 576 from both sides. We're starting to see some familiarity. Gone. A squared equals 100. So to undo a square, we do the square root. So a equals 10. Now we can see that one because it needs to be shorter than at least hypotenuse. Okay? Now we have another one. You guys, I'll pause it, try it, and then I'll start doing it. Well, I'll start doing it right now. So we're missing a leg. We're going to call this side A again. We'll call this side B, this side C. So a squared plus 11 squared equals 13.5 squared. I wonder if this one's going to come out nice. So let's do all the math we know. We don't know what a squared is. We know 11 squared is 121. And we're going to know that 13.5 squared, put in our calculator, is 182.25. So let's do the math again. Subtract, we miss a leg, we subtract. So this is gone because that cancels each other out. A squared equals whatever 182.25 minus 121 is. And that's 60. Whoops, I just made a line up there. 61.25. Remember, let's square root that. So a equals the square root of that answer, and I get an approximate. This is one of those irrational numbers. 7.83, let's say, meters. There's my answer. Okay, and that is shorter than the hypotenuse. Okay, so the last standard we're going to work with is just the same Pythagorean theorem, but now it's between 2 points. So if they gave us a graph and drew the line for us, gave us 2 points, you can actually see how we're going to draw a right triangle, okay? So I'm going to draw a line straight down. See how straight I can make it. So it lines up, that's pretty straight. It lines up with the other one, and now I have a right triangle. It kind of curved on me there at the last second. Then I find the distance between on these lines. So remember, this is my C. Let's just call this my A. This is my B. So A is 1, 2, 3, 4, 5, 6, 7, 8 units. So I'm going to use this equation right here, or formula. A squared, which is 8, we said, right? We said 8. Let's double check that. 1, 2, 3, 4, 5, 6, 7, 8. So 8 squared. And then B, 1, 2, 3, 4, 5, 6, 7, 8. 8 also. But we don't know what C squared is because we're going a diagonal. So, well, this one's not too bad. 8 squared is 64. 8 squared is 64 equals C squared. So I add those two up. That's 128 equals C squared. Remember, to undo a square, you square root it. So my answer is the square root of 128. But let's type that in, and I get, my answer is about 11.31. That's my C. Okay. So I got one more for you. And there's a few ways to do this, but the fail-safe way, if you have graph paper available to you, you can actually just graph the points. Okay, and then you can start thinking about how the x and the y's are related. But really, let's just graph the points. So let's graph point A first. Let me get a pencil. Point A, negative 5, 6. So we got to make sure we graph it right first. So it's negative 5 on the x and up 6 on the y. So 1, 2, 3, 4, 5. Then up 6. 1, 2, 3, 4, 5, 6. There we go. Right there. Let's graph the second point. We'll make that a different color. Point B is right 2 on the x and down 4 on the y. So 1, 2, 1, 2, 3, 4, right there. So let's draw our straight lines, or as close as we can get to straight lines. So there's one line, and then I'm going to draw, let me see here, let me make it trigger another one. I'm going to draw another one straight down until I line up. It's pretty straight. And then I'm just putting little dots over here so it does it again. And right here. So now we have our triangle. Now I just need to figure out, let's change the color one more time, the sides. So 1, 2, 3, 4, 5, 6, 7. So that side's 7. Okay, that's the distance between negative 5 and 2. And then let's find the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That one's 10. Okay, that's the distance between 6 and negative 4. So now we just don't know C, right? Let's change to a color that's a little bit darker. Let's use this one. Now we need to know my C. So 7 squared plus 10 squared equals C squared. So let's do the math that we have there. 49 plus 100 equals C squared. So it's 149 equals C squared. Now, to undo a square, you square root it. Now I know that 144 is 12, so it's going to be a little bit more than 12. Now let's type in my calculator, 149, square root of 149. And I got about 12.21 is about my C. I rounded it. Okay, so that's longer than my 10 and longer than my 7. So that's how I can check it. Okay, you guys, I hope you have a great rest of your week, and K-mail me if you have any questions.